Imagine a world without electricity, without steel machinery, without digital calculations, yet somehow able to build faster, larger, and more enduring structures than we do today. It sounds impossible, but the Romans did exactly that. Their roads still support modern highways. Their amphitheaters, aqueducts, and fortresses have stood for 2,000 years, while some modern buildings crumble in decades. How did they achieve this? What was the secret behind this impossible speed? The answer is not magic, and not even genius. It is a single word: standardization. The Romans were the first civilization to turn construction into a fully organized, almost industrial process. Every brick, every pipe, every measurement, every military camp, every road followed the same set of rules. An engineer in Gaul could send a plan to Syria, and it would be understood instantly. No confusion, no recalculation, no wasted time. It all began with standardized units: the Roman foot, palm, cubit, and the famous passus, the double step that defined the Roman mile. Every soldier, builder, and architect operated with the same precise system. With shared measurements, coordination multiplied in speed. Complexity disappeared. Even bricks became standardized. Roman brick factories produced uniform shapes and sizes, allowing legions to arrive at a new location and immediately start building without waiting for stone cutting or quarry preparations. This was the ancient equivalent of prefabrication. Their tools, too, were standardized. Every legionary carried the same dolabra, part axe, part pick, and 2 sharpened stakes used to build instant fortifications. It meant the army could become a construction crew in seconds. No need for supply wagons filled with equipment, no waiting, no delay. And beyond tools and bricks, Rome developed catalogs of architectural modules: arches, vaults, columns, and pillars with predetermined dimensions. An architect didn't have to recalculate the curve of every arch or the thickness of every vault. They simply assembled buildings like a designer, using proven, interchangeable components. This drastically reduced errors and accelerated construction. This systematic thinking extended to military camps. Every camp, regardless of where in the empire it was built, followed the same rectangular layout with identical street patterns, gates, and positions for tents, command posts, and watchtowers. A legionary arriving at a camp in Egypt or Britain could find his place without being told. Predictability saved time and saved lives. Even water pipes were standardized. Roman lead pipes existed in 15 fixed diameters, each with its own name. This allowed engineers to calculate water flow precisely and perform repairs quickly, replacing segments without custom manufacturing. Roman law supported the entire system. Construction contracts were extraordinarily detailed, describing every material, measurement, and process. The result was a construction engine unmatched in the ancient world, a conveyor belt of workers, modules, tools, and procedures that transformed an empire. But Rome's brilliance did not end with systemization. The true miracle lay in the hands of the legionaries themselves. We imagine them as warriors, but they were also masons, carpenters, surveyors, blacksmiths, and road builders. Each recruit was trained to fight and to build. The Legion was not just an army, it was a mobile labor force capable of transforming landscapes in days. Their greatest demonstration of engineering discipline happened every single night. After marching all day, the Legion stopped and immediately built a fully fortified camp. Moat, rampart, palisade, 4 gates, and thousands of tents arranged in strict geometry. It took only a few hours. This ritual removed the possibility of ambush, strengthened discipline, and created a sense of home wherever they went. But Rome's engineering might reach its peak with a material so advanced that modern scientists still struggle to replicate it. A material that shaped domes, harbors, bridges, and monumental structures that still survive today. That material was Roman concrete. Roman concrete, opus cementitium, was nothing less than a revolution. Its strength, durability, and ability to harden underwater made it the super material of the ancient world. The secret lay in its binding agent, a mixture of lime and volcanic ash called pozzolana. When combined with water, this mixture produced chemical reactions that formed crystals far stronger and more resilient than modern Portland cement. Unlike modern concrete, which deteriorates in seawater, Roman concrete becomes stronger. In marine environments, seawater triggers additional mineral growth that seals micro cracks. This is why Roman harbor structures remain intact after 2,000 years of waves and storms. The manufacturing process was efficient. Workers mixed lime, volcanic ash, and water into thick mortar, then combined it with stones or fragments of pottery. They poured the mixture into wooden molds, allowing it to harden into monolithic walls, arches, and vaults. This technique eliminated the need to carve and transport massive stone blocks. It allowed the Romans to build faster and with fewer skilled workers. Concrete enabled architectural forms that were previously impossible. Curved vaults, massive domes, and soaring arches. The Pantheon's dome, still the largest unreinforced concrete dome in the world, is a testament to Rome's mastery. Engineers even adjusted the concrete mixture as the dome rose, making the material lighter toward the top to reduce weight. But the Romans did not rely solely on material innovations. Their road-building techniques were among the most advanced in history. Roads began with precise surveying, using the groma and the chorobates, allowing engineers to lay routes in straight lines for kilometers, regardless of terrain. Workers dug deep foundations, layered stone, rubble, lime concrete, and finally fitted polygonal paving slabs so precisely that a knife blade could not slip between them. Roman roads were not just infrastructure, they were arteries of empire, enabling military response, trade, communication, and unity across vast territories. Logistics made all of this possible. The Roman state controlled quarries, forests, brick factories, and fleets of transport ships. Materials were moved by river, sea, and road with remarkable efficiency. Massive warehouses stored stone, lime, wood, and tools for mega projects like the Colosseum. There, workers operated cranes powered by human treadmills, lifting multi-ton stones into place with astonishing speed. Construction sites were divided into sectors, so different teams could work simultaneously. Tasks were broken into small, repeatable units. Discipline was strict. Deadlines mattered. Pride and competition fueled productivity. The result was a labor machine, capable of building at a pace that seems impossible even today. Aqueducts, one of Rome's greatest achievements, required extraordinary precision. With slopes measured in centimeters per kilometer, engineers carved channels through mountains, built towering arches across valleys, and guided fresh water into the heart of cities. Their waterproof mortar ensured crystal-clear water delivery for centuries. Inspection shafts, sedimentation basins, and distribution towers made maintenance efficient and reliable. At the pinnacle of construction stood the Colosseum. Built in under a decade, it showcased every Roman innovation: arches, concrete, modular components, cranes, and unmatched organization. It could seat 50,000 people, fill and empty in minutes, and support elaborate underground machinery controlling lifts, trapdoors, and stage effects. Behind every project was a hierarchy of architects, engineers, craftsmen, and thousands of workers. They were disciplined, coordinated, and supported by a system that valued speed, durability, and efficiency. Rome built not only structures, but a civilization, one brick, one road, one arch at a time. Their works endure as proof that engineering mastery is not about tools, but about systems, discipline, and the will to build for eternity.